Okay, so continuing on with polynomial operations, or using operations with polynomials, we've done addition, we've done subtraction, we're going to move on to the next one, which is multiplying. Now, since there are different types of polynomials, we got monomials, we got binomials, we got trinomials, we got higher termed polynomials. Since there's different types of polynomials, there's different methods we use to multiply them. So it's depending on what type of polynomials you're multiplying. Today we're going to start with the easiest one, which is multiplying a polynomial, so any number of terms, by a monomial, just one term. So multiplying a polynomial by a monomial. And like I said, the polynomial can be any number of terms. Okay, so the general sense of a polynomial could be anything. It could be one term. Or it could be multiple. So we'll say polynomial, any number of terms. And then the monomial, we're just going to multiply by one, or it's just going to be one term. By the definition of a monomial. So multiple terms times one term. How we do that is it's easy. It's using two things we've already done. So when you're multiplying a polynomial by a monomial, you're going to be using two properties that we've talked about. We're going to be using the distributive property, which we've done very, very early in the year and have used, throughout. And we're going to be using exponent properties, which we did in the last unit. Now, exponent properties, there's several of them that we did. We're mostly going to stick with the first few, which was, what happens when you're multiplying the same base together. Alright, so again, multiplying polynomials, starting with just multiplying a polynomial by a monomial, so any number of terms times one term. And we're going to be using the distributive and the exponent properties. Okay, so I'm just going to write down some examples, and then we'll go through the examples. And again, this one's fairly easy because it's just using properties we already know. Okay, so I have some examples written down, starting with basic, moving on to more complicated ones. Like I said, we're going to use the distributive property and the exponent properties. So I thought first let's just review what the distributive property is. Distributive property is what we use whenever there's a number, okay, or in these terms it's going to be a term, a monomial, in front of a group of parentheses, a group of terms inside parentheses. And what we do in the distributive properties, we just distribute that number that's out front. Okay, and when we distribute, we're going to be multiplying. So what this one is this is 5 times the polynomial 3x squared minus 2x plus 1. Okay. Remember, 5 is a polynomial. It's a constant polynomial. We usually don't call it a polynomial, but by its definition, it is one. So we're going to distribute this term of 5 into every single term inside of the parentheses. And when we distribute, it's going to be a multiplication. Now remember, you're allowed to multiply anything you want together. We're not allowed to multiply, or we're not allowed to add anything we want together, or subtract anything we want together. If we're adding and subtracting, we have to have like terms. When you're multiplying, the like terms don't matter, okay, because of the exponent properties. So when we're multiplying this, we can multiply 5 by each of these 3 terms on the inside. So we're going to do 5 times 3x squared. Okay. When you're doing a number, you just multiply the numbers together. 5 times 3x squared, 5 times 3 is 15. X squared stays. Alright, then 5 times the next term. 5 times negative 2x. Remember, whatever sign is to the left stays with that number. 5 times negative 2 is negative 10. And then the x stays. And then same thing with the last term. You have 5 times 1. 5 times 1. Multiplicative identity. Anything times 1 is itself. So it's just 5. Okay, and that's it. That's just distributive property. We've been doing that the entire year. Okay. Alright, so let's do one with an actual monomial. Alright. So on this one, we got negative 6x to the 3rd power. That's our monomial. Times a polynomial of 3x to the 4th minus 2x cubed minus x plus 9. Same thing we did in the last example, except now we have some different rules going on. So we're going to be taking this negative 6x to the 3rd power, and we're going to multiply it, again, to each of the terms inside of the parentheses. Now this is where you're going to have to recall exponent properties. What do we do with exponents when we're multiplying them together? Well, that was the first rule we did for exponent properties. When you're multiplying two of the same base, you add their exponents. So on this one, I'm going to write it out completely. So what's really happening here when we distribute is we're taking that negative 6x to the third power, and we're multiplying it by each term separately. So it's negative 6x to the third times 3x to the fourth. And it's negative 6x to the third times the next term, negative 2x to the third. So it's each one separately, negative 6x to the third times negative x, and negative 6x to the third times 9. Okay, now again, obviously you don't have to do this every time, but this is what's happening. Okay, this is all, it's written out completely. All right, and then again, these are just 4 of that first property in exponent properties. You're multiplying the same base together. What do you do with their exponents? You add their exponents together. Well, what do you do with the numbers in front? Well, the numbers in front, you just multiply them together. They're just numbers. We have negative 6x to the third times 3x to the fourth. Negative 6 times 3, those are just numbers. You multiply numbers together. The exponent properties, remember, are only for exponents. So when you're multiplying the exponents together, x to the third times x to the fourth, this is when you add their exponents together. So x to the third and x to the fourth multiplied together will give us x to the seventh. Again, so remember, addition and subtraction of polynomials, the exponents don't change. The like terms do not change. The variables and the exponents do not change. When you're multiplying, they do. Okay, again, because of the exponent properties. So same thing on the next one. We have negative 6x to the third times negative 2x to the third. Again, numbers multiply with numbers. Negative 6 times negative 2 gives us positive 12. And then the x exponents we're going to add. We got 3 and we got 3. 3 plus 3 gives us 6. So 12x to the sixth. Okay. Next term. Negative 6x to the third times negative x. Okay. Negative x, it's if there's not a number in front of a variable, the coefficient is 1. If there's not an exponent on a variable, the exponent is 1. Okay. So it's negative 6x to the third times negative 1x to the first. So multiply the numbers. Negative 6 times negative 1 gives you positive 6. And then add the exponents. Now again, if it helps, write the 1 in there. Okay. If anytime there's a variable without an exponent, it's a 1. So we got x to the third and x to the first gives us a total of 3 plus 1, x to the fourth. And then the last one is a negative 6x to the third times 9, just a number, no variable, no exponent. So we're just going to do negative 6 times 9, which is negative 54. And then the x to the third just stays because there's no other x's, so x to the third. So it's as easy as that. It's just recalling some of the old properties that we've been using. Okay, this next one has 2 separate pieces to it. So we have 15t times the binomial of 10y to the third t to the fifth, and then plus 5y squared t. Okay. So we got a monomial 1 term times a binomial 2 terms. We also have a second distribution we'll have to do, because we have minus 2y times the binomial yt squared plus 4y squared. So we're going to do distributive property with 2 separate terms, 2 different terms into 2 different polynomials. But we're going to deal with it the same way. All right, so I'm not going to write this one all the way out. I'm just going to explain it as I go. So the first one, we got 15t to the first power, if that helps, times 10t or 10y to the third t to the fifth. So start with multiplying the numbers. Multiply numbers. 15 times 10 is 150. The 15 doesn't have a y. So any y that's already there is just going to stay. So we got y to the third. And then it does have a t value. That's t to the first times the first term in the binomial is t to the fifth. So t to the first times t to the fifth, same base, so multiplying, so we add their exponents. 1 plus 5 gives us t to the sixth. Same thing on the second multiplication. We're going to do number times number. 5 times 15, 15 times 5 is 75. Okay. already has y to the second. And then the term we're multiplying into is also t to the first. So we got t to the first times t to the first. T times t is t squared. Add the exponents, 1 plus 1. All right, moving on to the next one. The next one we're distributing 2y, but not just 2y. We're distributing negative 2y because the sign to the left always stays. So we're going to be distributing negative 2y times both of these terms on the inside. So negative 2y times, well, the first term doesn't have a number in front. It doesn't have a coefficient. So it is a 1. You could put a 1 in. It helps. You could also put a 1 exponent on the y. So negative 2 times 1 is just negative 2. Our outside, our monomial, is also y to the first power. So I got y to the first times y to the first, which is y to the second. And then our outside monomial, what we're distributing, doesn't have a t, so anything with a t is just going to stay. All right, and then negative 2y times 4y squared. Multiply the numbers. Negative 2 times 4 is negative 8. Y to the first times y to the second. Multiply the y's together. 1 plus 2 is 3. Okay. So we're done with distribution. There's no more parentheses here. So now if we can, we're just going to try and combine like terms, if there are any. Remember, to be a like term, it has to have the exact same variables with the exact same exponents. So there's a lot of y's and t's here, but are any of them the exact same? Okay, so looking through here, we got y to the third, t to the sixth. There's no more of those. The second term is y squared, t squared. The third term is also y squared, t squared. So these are like terms. When you have like terms, you want to combine like terms. You want to write everything we can in simplest form. So when we're combining like terms, all we're doing is combining their coefficients, the numbers out front. Adding and subtracting like terms do not change the variables. So whatever we get when we combine these is still going to be y squared, t squared. So when we combine their coefficients, 75 minus 2 is 73. And again, the variables do not change. It's still going to be y to the second, t to the second. And then the rest of the terms, there's no like terms, so they're just going to drop down and stay the same. So 150, y to the third, t to the sixth, plus, a little offline here, plus 73y squared, t squared, which we got from combining like terms, and then plus, or in this case, minus the leftover term, which is negative 8y to the third. So you can always combine like terms if you can. So always check if you're, especially if you're doing, usually if it's just one distribution or one multiplication, there's not going to be like terms, because if there were, you could have simplified it ahead of time. But if you're doing multiple multiplications, always check before you circle your answer. Was there anything you could combine beforehand, before circling? Because we always want our answers in simplest form. All right, if you want to pause the video here and try this next one, okay, just a basic one, one monomial times a polynomial. Okay. Again, multiply the numbers, add the x exponents together, add the y exponents together, and then you're done. So if you want to pause it here, I'm going to wait about 5 seconds, and I'm going to put the answer up. So for this one, hopefully everyone got it. We're going to multiply all the numbers by 6. We're going to add 2 to every x exponent, and we're going to add 7 to every y exponent. Okay. Because that's what we do when we multiply terms together. So we're going to do distribution, 3 separate multiplications. All the numbers get multiplied by 6. All the x's get 2 x exponents added to it, and every y gets 7 added to it. So that first one had 7xy, xy to the first, or x to the first, y to the first. So add 2 to the x's, 7 to the y's, gives you 42, x to the third, y to the eighth. The second term, 6 times 3 is going to be, or 6 times negative 3 will be negative 18. X to the fourth, y to the eighth. And the last term, 6 times 15 is 90. Add 2 x's, x to the fifth, plus 2 is x to the seventh. And there is no y, so it's just going to be y to the seventh. So that's the basics of multiplying a monomial by a polynomial. Again, just distributive property. We threw in some exponent properties in there. There's one more type I want to look at. So these were just simplifying. This was, writing a multiplication as one polynomial. Okay. So there's no more parentheses, there's no more multiplying. We multiply, we simplify. None of these problems had equal signs. But these properties can be used to solve equations as well if there is an equal sign. So I'll give you a second to write this down, or you can pause it and write it down. This one's long. But it is just a bunch of simplifying. Okay. So we got some monomials times binomials. We have some constants in there. And we're going to see what happens. And notice that there is an equal sign in the middle. So when there's an equal sign in the middle, our goal is to usually, when there is an equal sign, we're trying to solve for x. Okay, so there's variables in here. We're going to try and solve for that variable because we know we have the left side that equals our right side. So we're just going to go through this piece by piece. So the first piece I see is, from left to right, I see this 2x that is being multiplied by a binomial. Again, anytime there's a number or a term in front of a group of parentheses, we want to distribute. So that's what we're going to do. 2x times 5x. Multiply the numbers, add the x exponents. X times x is x squared. 2x times negative 2 is negative 4x. Next distribution. We got positive plus 3x times 2x, which is 6x squared. 3x times 6, which is 18x. And then that plus 8 is still there. And nothing gets distributed though. Alright, so we're at the plus 8. Now we're into the equal sign. So now we're on the right side. Same thing on the right side. Anything on the outside is going to get distributed through. So in this one we have x. And we're going to multiply it to 4x. Gives us 4x squared. And then x times 1 is just x, 1x. So let's write x. And then it looks like there's one more distribution here. 2x, positive 2x, times the binomial 6x minus 4. So 2x times 6x is 12x squared. Again, once you distribute, you can drop the parentheses. 2x times negative 4 is negative 8x. And then you still have that plus 50 at the end. Okay. All right, so there's a lot here. When you're working with left sides and right sides, you want to simplify as much on the left as you can, simplify as much on the right as you can, and then worry about, switching sides if needed. So I'm going to worry about the left side first. On the left side, I'm going to try and combine any like terms that I can. So going through the left side of this problem, I have a x squared here, a 10x squared, and a little further down I have a 6x squared. So I'm going to combine those. 10x squared plus 6x squared. Now this is an addition. We're done multiplying. Again, there's no more parentheses. So now all we're doing is combining like terms through adding and subtracting. So again, adding and subtracting, we only add the numbers. We don't do anything with the variables or the exponents. So 10x squared plus 6x squared are like terms, so we combine them to get 16x squared. And move on to your x's. I got a negative 4x here and a plus 18x here. Again, they're on the same side, so you're just doing negative 4 plus 18. Negative 4 plus 18 is 14x. And then you still have that plus 8, the constant. Okay, there's no other constants on the left side, so it's just plus 8. All right, moving on to the right side. Again, same thing. Try and get your x squareds together. I have a 4x squared here and a 12x squared later on. 12 plus 4 is 16x squared. Go on to the x's. 1x minus 8x. 1 minus 8 is negative 7x. And then the 50, there's no other constants on that side, so plus 50. Okay, so now the left side is simplified as it can be. The right side is simplified as it can be. So now we want to get our terms together. We're trying to get, when we have x's on multiple sides, we want to try and get all of our x's on one side. Now there's a problem here. We've been solving linear equations, which means there's only been x's to the first, x to the first powers. Okay. On this one we have x squareds. Okay. Now sometimes that's going to be a bad thing. Okay, when there's more than when there's an x squared and x, because we can't combine those terms. In these problems, in these first problems that we're going to be doing, it's not a bad thing. Because if you notice, we have 16x squared on the left side, and we have 16x squared on the right side. So if we were trying to get our x squareds together, we'd have to subtract one from the left and one from the right, and since they match, since their numbers are the same, they're actually going to cancel out. So anytime you have the exact same match on the left as you do on the right, those terms are going to cancel out. So 16x squared, because it has a match on both sides, go away. Alright, so now we're just left with the equation 14x plus 8 equals negative 7x plus 50. This we can solve. We're going to get all of our x's on the left side, and we're going to move all of our constants to the right side. So this plus 8 needs to switch sides, so we're going to do minus 8 on both sides. The minus 7x on the right side needs to go to the left side, so we're going to do plus 7x on the right, which cancels out, which means we also have to do plus 7x to the left. So what are we left with here? On the left side, I have 14x plus 7x, which is 21x. Equals the right side. What's left on the right side? Well, the 16x squared went away. It's negative 7x went away. We're just left with 50 minus 8, which is 42. So I'm left with the equation now, 21x equals 42. And this is a one-step equation that we know how to solve. Divide both sides by 21, and x equals 2. So this big, long problem, we were able to get an answer from. It involved 4 distributions. It involved combining a lot of like terms, and then ultimately solving for x, something we've been doing this entire year. So again, just go piece by piece. Worry about the left side completely. Worry about the right side completely. Simplify as much as you can for each. And then worry about getting all your x's together to solve for x. Try this next one. Okay, pause the video, write the problem down, see if you can get the correct answer out. Alright, so hopefully you got an answer. I'm going to real quick run through this problem. First off, I'm going to need to get rid of all the parentheses by distributing whatever's in front of them through the grouping. So 3 times x is 3x. 3 times 5 is 15. That's just normal distributive property. The second distribution I need to do is negative x times the trinomial 2x squared minus x plus 1. So negative x times 2x squared. Okay. Again, there's no number in front, so it's really 1x to the first power. Negative x, negative 1 times 2 is negative 2. And then add 1x to the exponent, x to the third. Negative x times negative x. Again, that's negative 1x times negative 1x. Negative 1 times negative 1 is positive x to the second power. And then the last distribution here is negative 1x times 1. Anything times itself is itself, so they're really just negative x times 1 is negative x. Alright, equals. This term, the negative 2x to the third, is not what's being distributed. Okay, that's not in front of the parentheses. It's not in front of that grouping. It's not through a multiplication. It's its own term. So it's just going to stay negative 2x to the third. What is being distributed is the minus sign. Okay, it's negative. We're subtracting the grouping of x of 11 minus x squared. So when we have to distribute the negative sign to drop the parentheses. So instead of minus the quantity 11 minus x squared, we're going to write it as minus 11 and then plus x squared. Okay, when you distribute a negative sign, the signs flip. So in the grouping, the polynomial was 11 minus x squared. Now it's negative 11 plus x squared. Okay. Combine like terms, left side and right side. Now, same thing as the last problem. If there's anything that matches identically on the left side and the right side, we could cancel those out. So one thing I noticed is we have a negative 2x to the third on the left, and we have a negative 2x to the third on the right. We could cross those out. Those are going to cancel each other out if we try and combine like terms, because they match identically. Same thing with these x squareds. I have an x squared on the left and I have an x squared on the right. Both are positive. So if we tried to combine those, they would both cancel out. So we could just cross them out right away. Alright, so what's left over on the left side? I have a 3x and a negative x, so a negative 1x. 3x minus 1x is 2x. What else is left on the left side? We'll have a plus 15 with nothing to combine with. All right, what's left over on the right side? On the right side, everything's crossed out except for that minus 11. So that's all I have is minus 11. So what's left over? It's 2x plus 15 equals negative 11. This is just a two-step equation. So do the two steps that we know. Two steps are going to be subtract 15, leaving us with 2x equals negative 26. And then divide by 2 to give us x equals negative 13. So hopefully you're able to get that on your own. If not, hopefully you understand that a little better. Okay. Big mistake there is a lot of people just try and distribute. A lot of people will try and distribute the negative 2x to the third because it is in front of the parentheses, but it's not in front through a multiplication. It's in front through a subtraction. Okay. So only distribution on that side is just distributing the negative sign. All right, and that's the most basic form of multiplying polynomials, which is just a polynomial times a monomial, which again is just the distributive property mixed with our exponent properties. Okay, and the exponent properties being, there's numbers, you multiply the numbers in front, and then add the exponents.